To get started, we're heading to Mars. Using only one given value, your task is to determine three important measurements of the planet. Take about 4 minutes. Read the problem carefully, then try to solve all three parts on your own. After that, compare your work with my step-by-step explanation. By the end, you'll see how much information we can find from just one single value. Hello. Today, we will calculate approximately three important geometric quantities for a planet that repeatedly appears in the headlines. Mars. We will determine the circumference in the unit kilometers, the surface area in the unit square kilometers, and the volume in the unit cubic kilometers. For this, we may imagine Mars approximately as a sphere. In reality, planets such as Mars, the Earth, and other celestial bodies are not perfectly spherical. Usually, the radius at the equator is slightly larger than at the poles. Therefore, the given value is the mean radius of Mars. It is 3.39 times 10 to the power of 6 meters. This special way of writing numbers is called scientific notation. It helps us to work clearly with very large and very small numbers. In addition, it shows us exactly how many digits are truly important. These are called significant figures. You can recognize them by the number of digits before the power of 10. Therefore, the mean radius of Mars has three significant figures. Since our results are supposed to be given in kilometers, square kilometers, and cubic kilometers, we will now first convert meters into kilometers. For this, we use a conversion factor. We write it as a fraction. At the top stands 1 kilometer, at the bottom stand 1,000 meters. Both describe the same length. 1 kilometer is exactly 1,000 meters long. Therefore, the fraction has the value 1. If we now multiply the radius of Mars by this factor, the meters cancel out. What remains is the unit kilometer. We obtain 3.39 times 10 to the power of 3 kilometers. That means the radius of Mars is 3,390 kilometers. Part A, the circumference. Let us briefly note what this means. We are calculating the circumference of a great circle on the surface of Mars. For this, we use a well-known formula. The circumference is 2 times pi times r. We now substitute the radius of Mars. 2 times pi times 3,390. We calculate carefully and obtain 21,299. Since we are working with three significant figures, we deliberately round to the nearest hundred. In scientific notation, the result is 2.13 times 10 to the power of 4 kilometers. Part B. The surface area. Now we are dealing with the total surface of Mars. The corresponding formula is 4 times pi times r squared. We substitute the radius and calculate step by step. At first, we write down about 1 or 2 more digits than the number of significant figures. In this case, 1.44 times 10 to the power of 8 square kilometers. Then we round to 3 figures. The result is approximately 1.4, 4 times 10 to the power of 8 square kilometers. That is an enormous surface area, larger than all land areas of Earth combined. Part C, the volume. Finally, we look inside Mars. The formula is 4/3 times pi times r to the power of 3. We substitute the radius and calculate r to the power of 3. This gives 1.631 times 10 to the power of 11 cubic kilometers. After that, we round to 3 significant figures. The volume of Mars is then approximately 1.63 times 10 to the power of 11 cubic kilometers. All of this is not so difficult, right? As you can see, it is best if you have already worked through the task independently beforehand. That may be a bit of work, but in the natural sciences, doing your own calculations and thinking physically is the better way. Simply keep experimenting and stay curious. Have a great time, and see you next time.